Section 8.6, the focus on it is to determine from just the equation, the general equation, to determine what conic that it is. So I'm going to focus in up here on this general equation. And for all of these conics, or all the slices of a cone or two cones, you have it in this form, an ax squared plus bxy plus cy squared and so on. You do not, at this level, see this one at all, where the x and y are multiplied to each other. We look at that in pre-calculus because what happened here in this one, right now you're looking at hyperbolas, ellipses, parabolas that are all along the x-axis or all along the y-axis. What the xy term does is it rotates it slightly so that they're diagonal. So you would have an ellipse going this way or a parabola going this way, something like that. Well, we're not dealing with that now. There's enough here to know right now as a start. That's something for the future. But that's why we do ax squared plus cy squared and then all these others. Those two coefficients alone immediately tell you what kind of conic you have. You just have to memorize what they are. And this one tells you here. Okay. In a parabola, that's like the easiest one to tell because only one of the variables is squared. The other one's just not even there. So if the y is squared and the x isn't, then you know you're going to have x equals y squared. And so you have to have a parabola because all the others, circle, ellipse, and hyperbola, both the x and the y are squared. So parabola is easy to tell. In a circle, the a and the c are exactly the same. Same sign, same number. Okay? And think about that. Every circle problem you did was either x squared plus y squared equals 25 or 3x squared plus 3y squared equals 16, because you have to have the radius on the other side. But you always had the same exact coefficient for both. Every circle problem you did always had the same number for both. In an ellipse, it's the exact opposite. They can't be the same. See, an ellipse and a circle are the same thing, but an ellipse is just a circle that's been sort of pulled apart. And when that happens, in a circle, the radius is the same all around. As soon as you go like this, now the up and down one cannot be the same as the other one. If they were the same, then it would be a circle. So the way you determine the difference is just that A and C are different. But they have to be the same sign, because the only one that deals with a negative is the hyperbola. If the A and C have opposite signs, and it doesn't matter what the number, it can be 5x squared minus 5y squared, well, because that's a negative 5, it's really not the same as a 5, so that means they're still different. But the idea is as long as they have opposite signs, it's a hyperbola. You've seen other ways, if you've read and watched other things, and I forget if our textbook does it this way, where you can figure out the determinant, the b squared minus 4ac, and use that, and if it's equal to 0 or greater than 0 or less than 0, then you can tell. This is a lot less work. Just simply memorize the a and the c. So let's look at some of these problems. Okay, so on the first one, I see an x squared, I see no y squared. So what's that going to be? Anybody? There's an x squared, but there's no y squared. What type of conic? You can look up at the top 4 things to remember.
Parabola.
Parabola. It's going to be a parabola because in a parabola, one of the squares is gone. So I'll put a p here. Okay. This next, okay, let's look over 2. I have 2x squared and 2y squared. The coefficients are exactly the same. What's this going to be? When the coefficients are the same, it's going to be a circle. So because the coefficients are the same, that one's going to be a circle. Number 3, now this one has a trick in it. 4x squared minus 8x equals 4y squared minus 6y plus 10. It looks like the 4's are the same, but one of the things about this equation is they're on the same side. Right now in number 3, they're not on the same side. So I'm going to need to subtract this 4y squared and bring it over here. So it's 4x squared minus 4y squared, and now you know what this is. What's the only one that has a negative? Hyperbola. So as soon as it's on the other side and I see that because I had to move it, it's a negative, that means this one's a hyperbola. automatically a hyperbola. The next one is a trick one too, because you have to multiply this in, but frankly, I don't care about multiplying the squares. I get negative 8x squared, and this one is 8y squared, but they're on opposite sides, so let's move them together. So if I bring this one over here, I'll have negative 8. So if I bring this one over here and add it, I'm going to get plus 8x squared. Oh, so I'm adding 8x squared to both sides. Look, they're the same number. Which one's the same number?
Circle.
Yep, circle. So it's sort of, you have to do something to figure it out, but then once you get them together, you see that they're the same. So look at number 5 here. I see a y squared equals and a negative 4x squared. Let's add that 4x squared. 6y squared plus 4x squared. So once I move this to the other side, notice I'm ignoring the other numbers. The other numbers have nothing to do with this. If your only job is to figure out what type of conic it is, all you want to focus on is on the 2 squares. So I have a 6y squared and a 4x squared. Those two numbers are different. They're both positive. What is it when they're different? Which one of the conics? Anybody? We have 4 choices.
An ellipse.
Yeah, it's an ellipse. When the numbers are different, it's an ellipse. So, start with 9 down to 18. I want you to take a couple of minutes now to try to do some of these, to do them yourself. For some of them, you're going to have to move them over. Like this one's got to be moved over there to make it 3x squared minus y squared. But I want you to start figuring them out. The answers are on the back, so you can check the answers as you do them. Start with number 9, or you can do 6, 7, and 8. I don't care. You can do those too. But I want you to do a few of these for the next couple of minutes before we go to the next section. I want you to, you'll have at least 2 of these on the test, where you have to figure out, without making the equations for them, you have to figure out from just the coefficients, whether it's a circle, parabola, hyperbola, or an ellipse. As you do each one, check that answer on the back and see if you're right. If you're not sure why one is an answer, let me know and I'll explain it. Okay? Just tell me which number and I'll go over why it is a certain one. I'm going to warn you right now that for the 2 problems on the test like this, I'm going to ask you to tell me which conic and how you know. So you have to be able to say, well, there's only one variable that's squared for the parabola, or both the coefficients of the squared terms are equal for the circle, or the 2 coefficients of the squared terms are different numbers, so it has to be an ellipse, or one of the squared terms is negative, therefore it has to be a hyperbola. So you have to be able actually to write that for me for each one of those 4. There's other stuff they do in this section, but this is what I'm focusing on. So I want to make sure you get really comfortable with recognizing them. If you do, these will be 2 easy questions for you. You just have to remember those 4 little recognition points.